right, guys, today we are going to be talking about graphing sine and cosine functions. Okay, so sine and cosine are what is called a periodic function. Oh, here we go, periodic. Okay. Instead of graphing all the links that we found yesterday when we were doing all the spaghetti modeling, we're going to graph only some points. When you graphed yesterday, you graphed every single point that's on the unit circle from 0 to 2 pi that is defined for us. When we're doing these graphs, what we're going to be doing is we're only going to be graphing the maximums, minimums, and those x-intercepts that are so critical to this. And so right now, what I'm going to go ahead and give you here is if we consider what we have here, if I found my sine values at all of these points. So sine of, or sine not of, but sine at 0, so 0 radians would be 0, right? Sine at pi over 2 is 1. Sine at pi is 0. Sine at 3 pi over 2 is -1. And sine at 2 pi is 0. Remember, again, sine is just the y coordinate of the coordinate point at that given angle. So it is that vertical displacement. That's what we saw yesterday with the sine graphs. Okay, now cosine at 0 is going to be 1. Cosine at pi over 2 is 0. At pi, it is -1. 3 pi over 2 is 0, and 2 pi is 1. So those are all values that are on your unit circle that you should already know those values. Okay, so what I'm going to do is I'm going to use those values, and I'm actually going to use them to graph both sine and cosine. So if I go ahead and consider what I have here, if I look at this and I want to say that this is from 0 to 2 pi. So let's go ahead and do that. So this would be 0, obviously, because this is going to be my y-axis, and let's say this is 2 pi. Well, there's 1, 2, 3, 4, 5, 6, 7, 8 pieces, so halfway in between would be 4, so this would be pi, right? And halfway between 0 and pi would be pi over 2, right? And halfway between pi and 2 pi would be 3 pi over 2, right? And I think we can also agree that halfway between 0 and pi over 2 would be pi over 4. And halfway in between pi over 2 and pi would be 3 pi over 4. Again, if you're struggling with the concept here that I'm talking about halfway in between these fractions with this weird pi, just ignore the pi. What's halfway in between 0 and 1/2? 1/4. What's halfway in between 1/2 and 1? 3/4. You know, that's what I'm looking at right here. And so then again here, if I go between pi and 3 pi over 2, I'm going to get 5 pi over 4. And here between 3 pi over 2 and 2 pi, I would get 7 pi over 4. Okay. So this is what I'm going to have for my x-axis here, and this would be up to 1, and this would be -1. All right, so if I went ahead and graphed the function, let's see what that would look like. So here, if I go ahead and come up here, I go 0 is 0. So I'm going to go ahead and plot that point right here at 0. At pi over 2, I'm up here up at 1. At pi, I'm back down to 0. And then at 3 pi over 2, I'm at -1. And at 2 pi, I'm back here at 0. So let me go ahead and try and connect this without it being terrible. There we go. So here, that's going to be my graph of sine, and that should match pretty corresponding to what you had yesterday with your sine or your spaghetti functions. And then I think we can agree here at pi over 4, sine is equal to √2 over 2. Well, √2 over 2 is a decimal, and that's going to be a decimal equal to about 0.7. So it's less than 1, and if you can kind of see what we have right here, that's less than 1. If I was actually, good at doing this, it would be above halfway, and it would be about there. And that's exactly what I have here. And that would be what I would also have here at 3 pi over 4. Then at 5 pi over 4 would be -√2 over 2. 7 pi over 4 would also be -√2 over 2. But you notice here, these √2 over 2s and -√2 over 2s, they're not defined, like easy to identify, and that's why it doesn't really necessarily matter what those points are. What we're going to focus on here in order to do these graphs is that x-intercept, the maximum, x-intercept, minimum, x-intercept. Those are those critical points that we're going to be focusing on, okay? And so what we're going to go ahead and do is do the same thing, but we're going to graph cosine. So let me go ahead and label the x-axis. All right, so now I'm going to do the exact same thing. I'm going to go ahead and graph cosine. And so with cosine, I'm going to go ahead and at 0, we're at 1 pi over 2, 0. I'm just going to go ahead and mark these points here. So, and here, just so I can kind of have them all on the same screen at once. Zoom out a little bit so you guys can see everything. Okay. As much as I can. Okay. So right here, so at 0, cosine is equal to 1. So I'm going to start here up at this top part. At pi over 2, 0. At pi, -1. At 3 pi over 2, 0. And 2 pi, 1. And so I'm going to get this graph. Don't make it a V. It's not a V. That would be an absolute value graph. It's got a lot of curve to it. So there we go. So that's what I'm going to have for cosine. Now, let's go ahead and kind of compare the two of these functions side by side, and let's look at this. If you notice right here, I've got sine, it does this little S thing here. That's one way to kind of remember what we've got going on here. But one thing to keep in mind is this is going to continue. It's going to keep going just like this forever and ever and ever and ever. And it's going to do the same thing in this direction forever and ever and ever and ever. It's going to continue repeating over. It is what is called a sine wave. It is a periodic function that continues to repeat over and over in an infinite loop forever and ever. So does cosine. It's going to continue to do this, come down and come back up and do that. It's just going to keep doing that, and both of them will in both directions, okay? So they look very similar when you kind of consider the constant repetition of things. For example, I could go ahead and identify that I have the same exact cosine graph from here to here, right? Because that starts at that 1 and goes down to the -1 and comes back up to 1. The only difference is my x coordinates. Okay, likewise, I could do the same thing with sine over here on cosine is I could start my sine right here, and if I follow that, it goes here, 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 and then it ends here, and then it starts to repeat again. So you see, I have sine and cosine kind of within each other. They're just a shift from one to the other. So sine can be written as cosine, cosine can be written as sine. It just depends upon how you have the graph shifted, is what I'm trying to say. They are periodic functions. Again, that's very important to understand that they're periodic and it's constant repetition. And so that's what we're going to be kind of focusing on here. So speaking of periodic, so a sine function is periodic, and what that means is that it's going to repeat every 2 pi. Unless it's been changed. But if I went ahead and look at this, it goes from, like I have the same function right here from 0 to 2 pi, but it would also do the exact same thing if I went from 2 pi to 4 pi. If I continue that along, it would continue to repeat. Or if I went from 0 to -2 pi, it would be the exact same thing. So every single 2 pi, it's going to repeat. So it has a period of 2 pi. It has a domain of -infinity to infinity. There are no restrictions on my x-axis for a sine function. Anything could happen. My range, however, could I have -2 in my y values? Well, if you look at the graph that I have, if we go ahead and consider here, my maximum is 1 and my minimum is -1. Okay, so I can't have -2 or 2. It's between -1 and 1. So that's what my range is going to be. It's going to be from -1 to 1. Now, keep in mind that here I've got the square brackets on that right here because that's going to include the -1 and 1. I'm not using parentheses because parentheses means it does not include it. But sine is equal to 1 and -1 in multiple places. So it needs to include it. Um, Intervals of increase and intervals of decrease. I'm going to be a little bit honest. I'm going to come back to that after doing cosine, because I think it's going to be a little bit more easy to explain after explaining cosine. So I'm going to come back to that in a second. So let me go ahead and do characteristics of cosine. So cosine, same thing. So if I go from 0 to 2 pi, I have that, and then what happens after that? Well, it repeats. It's going to do the exact same thing. And that's because I have a unit circle and I'm just going around the same circle over and over and over and over again. I'm just going to keep hitting those same exact points. It's just my x-axis is going to have a larger angle as I'm increasing around the circle. So my characteristics for cosine, my period is 2 pi. My domain, same thing, negative infinity to infinity, nothing restricted on my x values. However, my range, same, -1 to 1. So let's talk about those intervals of increase and intervals of decrease. So if I went ahead and I looked at the graph that I've got right here, just this part that's marked right here, I can see from pi right here to 2 pi, I can see that my graph is increasing. So right here is an interval of increase. Okay, so I'm going to go ahead and say from 0 to 2 pi. Except here's the thing. Or no, why did I say 0 to 2 pi? From pi to 2 pi. But I can't just say just that, pi to 2 pi. Because what's going to happen when it's repeating here? Or over on the next cycle? Or over here when it's increasing here? So I can't just leave it at just from pi to 2 pi. I have to go a little bit more specifically. And what in the heck? um, I'm going to go from pi plus, and every 2 pi, it's going to repeat. So I'm going to do 2 pi k to 2 pi plus 2 pi k. And I'm going to say where k is an integer. Okay. So I'm saying pi to 2 pi k because this k represents how many times I've done a rotation around the unit circle. If I've gone around the unit circle 4 times, I would do pi plus 2 pi times 4. Okay, because that means I've done 4 repetitions around that circle. So that's just going to be the generic form of what you're going to do. So the way that you would do this, no matter what we have as this changes and go on through here, it's going to be wherever that minimum value is to the maximum value and plus whatever the period is plus a k. That's essentially what you're going to do. Intervals of decrease. So let's go ahead and let's look at what we have right there for that one. Decreasing from 0 to pi, right there. You can see it's decreasing. It's going to do the same thing here from 2 pi to 3 pi. And then we do the same thing from 4 pi to 5 pi. Okay, so you see it's going to continue to do that every single time. So if I come down here and say my intervals of decrease, so same kind of idea, I'm going to go, okay, so I have 0 plus 2 pi k to pi plus 2 pi k, where k is an integer. This k is an integer part is also important because that's stating that all I can plug in there is an integer value. I can't plug in 0.2 because 0.2 rotations around the unit circle would not get me what I need for that repetition. It's 2 pi and it's integer repetitions. So if you notice here, if I go from 0 to pi and then pi to 2 pi, that includes my entire unit circle. That gets me from 0 to 2 pi if I go through everything. And that gets me that it's increasing or decreasing that entire time. And I can see that decrease to increase, then it goes back to decrease to increase, decrease, increase, so on and so forth. Okay. So now if we go ahead and come up here and look at sine, I want to talk about that one now. Sine's a little bit more confusing to see right out the bat because that interval of increase, you see I've got this whole section right here that also is increasing. That is not part of my graph that I originally graphed. Likewise, I have this part right here, but I don't have this part of the graph actually physically graphed. So it's right there that would be kind of confusing for some people. So what I'm going to state is right here, this minimum value, it's coterminal to 3 pi over 2. So let's consider what we have there about that. So if I have 3 pi over 2 right here, okay, what is coterminal going in a negative way? Well, that would be negative pi over 2, right? Well, that's exactly what I have right here for that point. This right here would be negative pi over 2. So from negative pi over 2 to pi over 2 is where I have an increasing interval. Likewise, from 3 pi over 2 up here, up to my maximum of 7 pi over 2. Oops, sorry, 5 pi over 2. I don't know why I said 7. 5 pi over 2, right here. So that's what I'd have for those. So what I'm going to go ahead and say here, my interval of increase, I'm going to say from negative pi over 2 plus 2 pi k to pi over 2 plus 2 pi. And then I'm putting parentheses around it. Now, if you notice, you put parentheses around all of these because you can't say that it's increasing or decreasing right here at pi, for example, because that's a turning point. Okay, that's where I'm going from decreasing to increasing. That's a point that has neither increasing nor decreasing. Likewise here at 2 pi, and same thing here at 0. And then same thing here when I'm looking at sine. Here I have at pi over 2, 3 pi over 2, and then 5 pi over 2. Those are turning points, so I can't include those kinds of things, okay? And then so we have from negative pi over 2 to pi over 2 plus 2 pi k. I don't know. I just realized I wrote that as 2 pi over k. Let me fix that. 2 pi k. Derp. So then we have where k is an integer. All right, intervals of decrease. So let's go ahead, let's come back up here and let's look. So intervals of decrease in this particular case, I have from pi over 2 to 3 pi over 2. Okay, so intervals of decrease are easier to see on the sine graph. It's just the interval of increase that's more difficult to see on this part. So it would be from pi over 2 to 3 pi over 2. Okay, so I can do that. So I'm going to say pi over 2 plus 2 pi k to 3 pi over 2 plus 2 pi k. Again, not including anything, and then where k is an integer. Okay, so let's talk about similarities and differences. Well, I've been kind of talking about them all throughout all of this. So a lot of these similarities are coming down to where they have the same maximums, the same minimums. They're just in different locations. They have the same x-intercepts, same period. Everything like that is all the same. It's just a phase shift, which we'll get to later what that is. It's just a shift of the graph from one to the other, just a horizontal shift. Okay. Um, so similarities, let's go ahead and write some of those out. So same period, same max, min, okay. So they both have a maximum of 1 and both have a minimum of -1. They both have the same domain. Yeah, it's not how you spell domain. Domain. Um, so they have all of those things that are the same. Okay. Um, the differences are is that they're just slightly different from one another. The different part is kind of what I was getting at earlier when I was trying to show you that they have a lot of similarities. Um, if I consider what I have, let me see. Let me use this right here. This is cosine, right? I kind of mentioned that earlier. Okay, so this is cosine, and that goes from pi over 2 to over here to 5 pi over 2. Okay, likewise, I have sine, which would be here negative pi over 2 to 3 pi over 2. They're a phase shift either, or I keep saying phase shift, and you guys don't know what that means. Um, they're a horizontal shift. That's what a phase shift is. It's a horizontal shift of my graph, right or left, and it just kind of depends upon how you look at it. It's a shift by pi over 2 from one to the other. So that's kind of what you're looking at here for the differences. So um, shift of pi over 2 from one to the other. Okay. So we can see they have the exact same values that we put on the x-axis here, the same y values that we put on here, and it's just, just moving one to the other from side to side is essentially what you're doing. Okay, so since the sinusoidal function has a limited range, we can talk about its height, known as the amplitude. Okay, amplitude. Amplitude is going to be what you are considering when you're looking at how high up something goes. The amplitude of something is going to be the change from the middle of the graph to the top of the graph. And so that's what it's saying here is it's talking about its height. I want to make sure that we understand that that height is this difference here. Okay. It's from the middle, so the x-axis. Well, I shouldn't say x-axis. It's called our midline, is what we're going to do. And right here, that's going to be the midline right now without having moved our graph up or down at all. That is the x-axis, but it's not always going to be the x-axis. It's the distance from that midline to the maximum point. So, what we're going to go ahead and do with that information, the amplitude, if you kind of consider what we've done previously, um, and I've written it like this for you guys several times where you have a f of some function b x minus c plus d. So this is what you guys are kind of used to seeing. Um, Sometimes instead of C, you might have H. Sometimes instead of D, you might have K. It just kind of depends. I think I've used both of these interchangeably with you guys throughout the year. But anytime you have a number multiplied by your entire function, when you're talking about what all of these things are going to do for your function, let's kind of remember what they're going to do. This right here is that vertical stretch, right? Or compression. It's the thing that's going to make the graph a bit taller or shorter. This one was the horizontal stretch or compression. This one was the shifting left or right. And this one would be shifting up or down. Okay. So this vertical stretch part right here, that's sure enough, that's exactly what we were talking about right here for amplitude. So the number that's out in front of your function is going to be what's going to define your amplitude. So if I consider my parent function of y equals sine x, for example, my amplitude is 1. That number in front is 1. It goes up to 1. It goes down to negative 1. Now, if I come here, I have a 2 in front. It's going to go up to 2, down to negative 2. That's what my amplitude is. The amplitude is always going to be the absolute value of the number that is multiplied by your trig function in front. of it. So my amplitude would be 2 here. And again, it's going to always be the absolute value. It is a positive number. Amplitude is positive, always positive. It is a height. It is a measurement of height. You can't have a negative height, so it will always be a positive number. If you give me a negative number, it will be wrong. So likewise right here, I have negative 1/2 cosine x minus 5. Well, the number that is multiplied out front of the trig function is that negative 1/2. So my amplitude is 1/2, not negative 1/2, 1/2, because it is always positive. Okay, right here, 9/2 sine times x minus 3 plus 1. Well, I got 9/2 right here. And you know what? I'm going to go ahead and just state right here, I could, because these are side by side right now, I could go ahead and say that this minus 3 right here, that means that I would be moving my graph to the right 3, and this plus 1 right here would be moving my graph up 1. That should be stuff that we should be familiar with. Likewise, right here, this would move my graph down 5. But these are things that we're going to get into later, so don't stress out about it right now. Okay, so let's actually graph some things right now. All right, so if I have 2 times the sine of x, what I'm going to go ahead and do is I'm going to fill in this table as I have it right here. So if I have sine x, sine at 0, well, we already know sine at 0 is 0, pi over 2 is 1, pi is 0, 3 pi over 2 is negative 1, and 2 pi is back to 0. So that's what I have here. So now what I need to do is I need to figure out, well, what would be 2 times sine x? Well, what is 2 times 0? 0. What is 2 times 1? 2. What is 2 times 0? 2. What is 2 times negative 1? Negative 2. What is 2 times 0? 0. So you see, this sine x is that whole column right here. So I'm just doing 2 times whatever I have right here in this column. So 2 times each one of these values is what I'm getting here. Okay, so now I'm going to go ahead and graph this. Now notice I'm just giving just this horizontal line. It's not labeled in any way, shape, or form. I'm going to go ahead and do that for you guys. So what I'm going to do is I'm going to go ahead and give myself a y-axis right here. And I'm going to go ahead and label that as 2 as my maximum and negative 2 as my minimum. And I can do that because if I'm looking right here, well, my maximums on my original one were 1 and negative 1, and now so they've just been increased to 2 and negative 2. And that matches my amplitude, which again, the amplitude is the number that's multiplied out front, and it's the absolute value of it. So I've got that information. And now what I can go ahead and do is go ahead and plot my points, essentially. So I'm going to go ahead and mark just a few things. So I'm going to go pi over 2, pi, 3 pi over 2, and 2 pi. I don't need to make a tick mark for 0 because this is 0. All right, so let's go ahead and let's graph this. So at 0, I'm here at 0. At pi over 2, we're up at 2. At pi, we're back at 0. 3 pi over 2, negative 2. 2 pi, back at 0. So I have, this is my graph. So it looks exactly like our parent function that we already graphed just a few minutes ago, but the only difference is that it goes up to 2 and down to negative 2 instead of 1 and negative 1. That's it. That's the only difference. So let's go ahead and identify these various different information here. So period, how long until it starts to repeat? Well, I just drew the whole period from 0 to 2 pi. So that's 2 pi. My amplitude, 2. It's the absolute value of whatever's multiplied out front of the trig function. Range, well, let me do domain first. Domain would be negative infinity to infinity. Range, I'm going to go from negative 2 to 2. Intervals of increase. Oh, again, that's going to be negative pi over 2 plus 2 pi k to pi over 2 plus 2 pi k. That's it. Okay? I get the negative pi over 2 to pi over 2 because, again, that's that continuation of this function right here, and it would be from here to here. All right, let's see what we got right here. So -3 cosine x. So again, let's just do cosine x. So cosine at 0 is 1. Cosine of pi over 2 is going to be 0. Pi is 1, oops, -1. 3 pi over 2, 0, and 2 pi back to 1. So let's do -3 times each one of these. So -3 times 1 is -3. -3 times 0 is 0. -3 times -1 would be 3. -3 times 0 is 0, and -3 times 1 is -3. Okay, so let's go ahead and make our graph. All right, so we're going to make this be -3 and this be 3. And again, I'm just going to make a few little tick marks on here just to match whatever I've got on my table right here. So I'm going to go from 0 to pi over 2, pi, 3 pi over 2 to 2 pi. So here's the thing though, is that with all of these, you're not always going to be given a table to fill in. The reason that I know that it's these values is because I know that I've not changed my period in any way, shape, or form. I've not changed my graph right or left or anything like that. All I'm doing is just changing my amplitude. I'm just changing how high or how low it goes. So I'm just going to use these values right here that are given to me. Okay. Um, so now if I go ahead and go in here at 0, cosine is -3, and this one. Pi over 2 is 0. Pi is 3. 3 pi over 2 is back to 0, and 2 pi is at -3. So we've got like this kind of thing going on. Now, if you compare this right now to how it looked right here, notice here it started at the top at 1, went down to the bottom at -1 at pi, and back up to the top at 2 pi. Let's come back to this one. It starts at the bottom at -3, goes up to pi, and then comes back down to -3. So, what do you think could be causing that change? Well, remember that if there's a negative in front, that also is a reflection across my x-axis. And that's exactly what's happening. So instead of starting at 3, we reflected and went down to -3. Instead of being down here at -3, we reflected across the x-axis, and now we're up here with +3. So that's exactly what's happening there. All right, so my period here, again, there's been no change to my period, so it's just 2 pi. My amplitude is 3. Again, it is not -3. It is the absolute value of the number that is multiplied by the trig function, so it would be +3. My domain would be -infinity to infinity. My range would be from -3 to 3. Intervals of decrease. So where is this decreasing? Right here in this whole section right here. So what are those values? Well, that's from pi to 2 pi. So, not the square bracket. We're going to go pi plus 2 pi k to 2 pi plus 2 pi k, where k is an integer. Ooh, if we had been in class, there would have been a piece of candy available here. I left off where k is an integer. You always need to state that whenever you're using k in this instance. Okay. Oh, there's really not enough room for this over here. Let me see if I can go ahead and move this a little bit better. All right, so let's go ahead and try what we have right here. All right, so 1/2 of sine x. So remember, sine at 0 is going to be 0. Sine at pi over 2 is going to be 1. Sine of pi is going to be 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is back to 0. So doing 1/2 of each one of these. 1/2 of 0 is still 0. 1/2 of 1 is 1/2. 1/2 of 0, 0. 1/2 of -1, -1/2. 1/2 of 0 is 0. Okay. So I'm going to go ahead and graph these. And so now I can see that that highest number I'm going to need is 1/2, and the lowest number I'm going to need is -1/2. So I've got 1/2, -1/2. And so I'm going to go ahead and label this x-axis pi over 2, pi, 3 pi over 2, and 2 pi. Okay. So now I'm just going to go ahead and plot my points. So I got 0, 0. At pi over 2, we're up at 1/2, so we're up at the top. At pi, we're at 0. At 3 pi over 2, we're at -1/2. And at 2 pi, we're back to 2. Or back to 0, I should say. So that's what we got. Okay, getting better at drawing these. I'm so out of practice using the sketch pad. Okay, period, that hasn't changed. 2 pi. Amplitude. Amplitude here is going to be 1/2. Domain, -infinity to infinity. Range, that's going to be from -1/2 to 1/2. Intervals of decrease. So again, I'm going to look at my graph right here. Where is my graph decreasing? Where, if I placed a ball on my graph, where would it roll downhill to the right? Well, that would be right here. So that would be from pi over 2 to 3 pi over 2. So I'm going to have my interval of decrease would be from pi over 2 plus 2 pi k to 3 pi over 2 plus 2 pi k. Okay, so that gets you through all of this. Oh, I keep forgetting it. Where k is an integer. So I know I need to keep getting myself in the habit of writing them where k is an integer, so you guys are also going to need to get yourselves in the habit of doing that. So it's just a kind of annoying thing. You can shorthand it, where you can say that k is an element of the set of integers k, this little e and a z here. You can do that, but it has to have that double bar z. This is shorthand for integer right here. So that is one way that you could do it, but I don't necessarily recommend that. Where k is an integer is perfectly fine. But this should get you through everything that you need for today's assignment. Hopefully that makes sense. Let me know if you have any questions.